In this problem, we're going to find I sub 1 and current I sub y using Ohm's law, Kirchhoff's voltage law, and Kirchhoff's current law. We start by selecting terminals x and y, and we're going to find an equivalent network for that. So we write 40 volts source and the 3 ohm resistor, the two 3 ohm resistors, and then a box with voltage vis-a-vis across it. So we know that 4 amps goes in, 4 amps goes out, and we want to find vis-a-vis. So we write Kirchhoff's voltage law around the loop, and we write 40 volts equal to 3 times 4 amps plus BA plus 3 times 4 amps. This is going to be equal to BA 40 minus 24 equal to 16 volts. Next, we're going to work with the middle section of the circuit, and we're going to redraw it with 16 volts across the resistor in the middle. We know that 4 amps will flow into node number 1 and 1 amp will flow out of node number 1. So we need to determine what currents flows through the two branches in the middle. And so we write that the first one, I sub B, will be equal to 16 volts divided by 16 ohms, 10 plus 6, that's equal to 1 amp. So 1 amp is flowing through one of the branches of the resistors in the middle. Now we need to find the other current in order to determine I sub 1. So for that, we call that current I sub x. I sub x is equal to 16 volt divided by R1 plus 1. And we notice that if we perform a Kirchhoff's current law at node number 1, then we can have 4 amps going in, and then 1 amp plus 1 amp going out, and that will be equal to I sub x. So I sub x is going to be 4 minus 1 equal 2 amps. And if we put now I sub x equal to 16 divided by R1 plus 1 equal to R1 will be equal to 7. So the resistor R1 is equal to 7 because 7 ohms plus 1 ohm is 8, and 16 volts divided by 8 ohms is equal to 2 amps, and that was the value that we found for current I sub x. Now to determine I sub y, we need to move to the last part of the circuit, and this will be an analysis at node number 2. We notice that we have 1 amp flowing into node number 2, and then across the 2 ohm resistor we have 8 volts, and then we have current I sub y going into node number 2. So if we write current I sub b as the current going through the 2 ohm resistor, we find that that current is equal to 4 amps. Now Kirchhoff's current law at node number 2 is 1 amp plus I sub y plus I sub b is going to be equal to 4 minus 1. I sub y must be equal to 3 amps in order to make that current I sub b equal 4, and 4 times 2 equal 8 volts. And that's the solution to this problem.